This first video, I'll go through questions 1 through 5. Starting here with 1A. 1A asks, what's the probability that z is less than 2.61? Well, that's going to be the area under the curve to the left of a z-score of 2.61. 2.61 is going to be way off to the right here. You can see it indicated right there. And to find out what the area is below the curve to the left of that, we go to our table of z-scores, come to the left column to 2.6, and then over here for the hundredths digit, 0.01. So this would be the area corresponding to or to the left of, under the curve to the left of a z-score of 2.61. And we see that indicated here, 0.995, not there, here, 0.9955. So that's this blue area here. Part B asks us for the probability that z is greater than negative 1.53. Greater than means that means an area under the curve to the right of, in this case, negative 1.53, and there it's indicated right there. And so to find that, we again go to the table of z-scores. However, when we go to the z-scores, what we're going to find is the area to the left. And we will then need to subtract that from 1, which is the total area under the curve. Excuse me, I go to the table of z-scores again, the left column, negative 1.5, and the third column here is 3 and hundredths place. So this area, 0.630, is the area to the left of negative 1.53, the area under the curve to the left of negative 1.53. And so that's the area right there that we subtract from 1 to get this area, the green area, to the right. Alright, and then the last part of that first question, part C, asks for the probability that z is between negative 1.27 and positive 2.08. So the probability that z is greater than negative 1.27 and less than 2.08. So that's the area under the curve between z-scores negative 1.27 here and 2.08 here. So what we're going to get from the table is a large area to the left of 2.08, and then we'll need to find this area, the smaller area, to the left of negative 1.27, and subtract this smaller area from the larger. So we go to our z-scores again, and z here 2.0 in the left column, and 8 in the hundredths column over here. You see that they intersect at an area of 0.9812. So that will be the area to the left of 2.08. So there it is, 0.9812 in our calculations that we'll look at in a second. Then we need to find this smaller area to the left of negative 1.27. So we go to the negative z-scores. Down this left column again is negative 1.2, and for the second digit, the hundredths digit, we go to this column, 0.07, and where those intersect is an area of 0.1020. So that is this area, this smaller blue area to the left of negative 1.27. So I subtract that smaller area from the larger, and I have 0.8792. So that's the answer to part C. Now number 2, in number 2, we're given some x values. We're given some values in a data set. And we want to find the probability that given the fact that this data set is normally distributed and the mean is 67 and the standard deviation is 11, what is the probability that a particular x is greater than 60 and less than 80? So we take each of these x values, the 60 and the 80, and convert them to z-scores so that we can compare them on the standard normal distribution. So that's x minus mu divided by sigma, 60 minus 67 divided by 11, and that's approximately 0.64. Remember, we round z-scores to 2 places because that's how far our table goes. The other z-score corresponding to an x value of 80 is 80 minus 67 divided by 11, and that gives us a z-score of 1.18. Don't forget, if you're doing this on a calculator, to put parentheses around your values in the numerator before you divide. So here's our two z-scores, and just like we did above in part C of question 1, we're going to have a larger area that we will subtract a smaller area from. Excuse me. So the probability that z is greater than negative 0.64 and less than 1.18 is that larger area, the probability that it's less than 1.18, minus the probability that it's less than negative 0.64. So we start with the larger area by going to the positive z-scores and looking up the area corresponding to 1.18. So here in the z column we go to 1.1, and for that hundredths digit we go to the 0.08 column. That intersects at 0.8810. So that is the probability that z is less than 1.18. It's the larger value, it's the larger area. Then we subtract the smaller area corresponding to a z-score of negative 0.64. And to do that, again, the negative z-scores this time. So we go down this column to find the negative 0.6, and to this column for the 4 in hundredths place, 0.04. And those overlap at an area of 0.2611. So that's the smaller area that we subtract from the larger, and that gives us a probability of 0.6199 that an x value would be between 60 and 80. Part 3 asks us to find the z-scores separating the middle 94% of the standard normal distribution. Well, this white area is an area of 0.94. It corresponds to a proportion of 0.94, which is the same as a percentage of 94%. And so if this white area is 0.94, then the blue area put together, both of them put together, is the remainder, is the complement, is 0.06. And that makes the area in each of these tail sections half of that, or alpha over 2, 0.03. So this area is 0.03 and this area is 0.03. So what we need to do to find this z-score and this z-score is look up an area of 0.03 on our z-scores. Since that area is very small, it's going to be in the left half, so we look at the negative z-scores. And we look in the body of the table. We look in the body of the table to find 0.03. So here's 0.00, 0.125, 0.2, 0.25. Okay, we're closing in. Oh, there it is. How come I didn't see that? It's got this orange rectangle around it. It's 0.0301. That's as close as we're going to get. That is 1/10,000ths away from the value we're looking for, and so there's the area, 0.0301. So we see what z-score corresponds to that, and it's here on this white line, negative 1.8, and for the value in the hundredths place, we come up here, and the digit in the number in the hundredths digit is 8. So the z-score is negative 1 1.88. Well, if this is negative 1.88, this is going to be positive 1.88 because the standard normal is, and any normal distribution for that matter, is symmetrical. The standard normal is perfectly symmetrical. So our z-scores are negative 1.88 and positive 1.88, and the way we indicate that is with plus or minus. So z is equal to plus or minus 1.88. Alright, number 4 is an application. It says that birth weights in Finland are normally distributed with a mean of 3,750 grams and a standard deviation of 500 grams. And so it says, suppose a hospital requires special treatment for newborn babies weighing less than 2,800 grams. What percentage of newborn babies require special treatment? Well, the mean is 3,750, so that's going to be our value down the middle. And then all of the x values to the left of that will be lower than that. And so we use this mean that we're given here of 3750 and this standard deviation of 500 to convert this value, this data value, 2800, which is the one we're interested in, to a z-score, so that we can then use that in the standard normal to determine the area, proportion, probability below that particular z-score. So again, we use our formula, x minus mu divided by sigma. The x is 2800 because that's the particular value we're interested in. We subtract it from the mean, or rather we subtract the mean from it, and divided by 500, and that gives us a value of negative 1.9. So we go to our negative z-scores, negative 1.9, right here, to find the area that corresponds to it. Well, that's going to be in the first column because the excuse me, the hundredths digit is 0. So the area under the curve to the left of negative 1.9 is 0.0287. That's this value here, right there. So excuse me, 0.0287, move the decimal 2 places, and that gives you 2.87%. So 2.87% of babies are going to require special treatment, and that seems to make sense. It's a very small percentage. That's the kind of thing that we might expect. We might expect a small percentage of newborns to require that kind of treatment. Okay. I said I would do the first 5 questions, but I feel like the video is getting a little bit long, and I know there's something a bit to do in the rest of this might be time consuming, so I think that I will cut it off right here.